Hi, everybody. Today we're going to do quadratic formula. This is BB.11 from Algebra 1 IXL. So I haven't previewed it, so hopefully it'll give us some that we're probably going to get an estimate. So I have my calculator ready. Okay, so we're supposed to use the quadratic formula for this. So remember what the quadratic formula says. If we have a standard form quadratic in the form A, in this case, W squared, plus BW plus C equals 0. We usually use the X's, but W's work just as well. Where A, B, and C are the coefficients in the terms, then we have W squared plus 2W plus 1 equals 0. In this case, there is a 1 in front of that W squared, even though you don't see it. So A is 1, B is 2, and C is 1. And we are substituting into the quadratic formula, which says, in this case, W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Now, for this particular case, I'm going to go ahead and substitute it in really carefully. We have negative B. Now be very careful, because when the B is negative, remember that it's going to end up, negative B is going to end up being positive. In this case, since B is positive 2, it's going to end up being a negative 2. Plus or minus the square root, B squared, and it is important that you put the parentheses, and I'll tell you why in a minute, minus 4 times A times C. Now I do make a little change here. When I'm writing my formula, I like to make this plus a negative 4. It just makes things a lot more handy and a lot easier to follow as far as the arithmetic goes. And the A is 1. So I'm going to simplify all this. Oh, in just a minute. A is 1 and C is 1 as well. Now remember, you are multiplying these guys together. So we end up with, sorry, it's a little bit, hopefully it's easy enough to see, plus or minus the square root. In this case, we have 4, but we also have plus a negative 4, all over 2. Now we end up with negative 2 plus or minus 0 over 2. Well, we only end up with one answer. And the reason is this is a perfect square trinomial. Now, clearly, it would have been a lot easier to see that this was W plus 1 squared equals 0, in which case the only solution is negative 1. But of course, our quadratic formula also gives us, well, I'll write it as negative 2 over 2, which is negative 1. So apparently I'm supposed to put in both answers. So I'm going to put in the negative 1 and also the negative 1. Of course, there's only one real solution. All right, let's go a little faster on this one. So now we identify my A, B, and C. So A is equal to that 1 in front of the F squared. I'll just write them over here. B is equal to the 6, which is in front of the F. And C is equal to 9. And our answer, F, is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. Now, what I'm going to do in the future is that I'm not going to write out the formula. I'm just going to put the parentheses, and I'm going to slowly increase the speed on this just a little bit. Minus, remember I like a plus and negative 4. You'll find out why that's important if you do enough of these. And we'll put in our A, B, and C. So in this case, we have negative 6, because the 6 gets substituted in. We have a 6 squared, and we have 1 and a 9 over there, and 2A is 1. And here's 0 again. We have 36 plus negative 36, which gave us our 0. So F ends up being negative 6 over 2 which is just -3. That's our only solution. And of course, the reason is this polynomial, this trinomial, is really just f plus 3 times f plus 3. It's equal to 0. And the reason they ask for two different answers is that they're wanting the 0 for this one and the 0 for that one. This happens to be -3 and -3. Just as a side note, something interesting, whenever you get a double root like this, you end up touching your x-axis at that point. So if I were to graph this thing, it would be a standard parabola. At -3, we would have a vertex and it would just go up from there. And it would touch it at -3, just at that point. Anyway, something to think about. All right, let's see. Okay, this one is not a perfect square trinomial. So we are going to get two solutions. I suspect that it's not factorable if I'm just looking at it. No, it's not factorable. And we can go ahead and work our little magic here. A is equal to 3. That's the coefficient on the squared term. 3 is my B also. And C is equal to, be careful, remember that it's always plus C. Well, this is the same as plus a -8, which is the reason that my C is -8. So let's put in our values. So I'm going to go ahead and write y in this case is equal to -b plus or minus the square root. Notice what I'm doing. B squared plus -4ac all over 2a. And I just substitute in my a, b's, and c's. B goes here and here. A goes here and here. And the c goes in here. Now, the reason why I like to make it a -4 instead of a -4ac is that the subtraction is really adding the opposite, and you end up with subtracting a negative, and it's just a big hassle. When you multiply those together, you end up with the 96, and it's just so much easier. So we get y equals, this is -3 plus or minus the square root. Now this right here is 12 times 8, which is 96. And then double negative makes it positive 96. And 9 plus 96 is 105. And it's over 6. Now, a very, very common mistake is to want to cancel that 3 and that 6. Be very careful. That 6 is a common denominator. Now, this is my answer right here. Now, we're supposed to simplify this and get an approximation. Now, I happen to know that the square root of 105 is approximately 10.25, more or less. So I could probably get it pretty close, but it's better to use a calculator on this. So I'm going to use my calculator and round it. I'm taking the square root of 105, which is 10.25 if we round it. -3 plus or minus 10.25 over 6. Now, in this particular case, I am going to go ahead and use the calculator to simplify this because the dividing by 6 could give you a little bit of trouble. You also may, before you round it, you may want to go with just a few more decimal places because when you do the division, it can mess it up. So I'm going to go ahead and go just a few more decimal places. 2, 4, 7. That's going to be far enough. And then I can go ahead and I'm going to add my 3 and divide by 6. And I get -2.21 when I round it to the nearest hundredth. Yeah. And then my other one is going to be the difference. So I'm going to take the square root of 105. And I'm going to subtract the 3 and take the square root. No, divide by 6, sorry. There it is, 1.21. Now, one thing you want to notice is that my decimals end up being equal, which is interesting. That's an important idea, and it generally will be either they'll be equal or they'll be conjugates of one another. Conjugate for 21 would be 79. Anyway, just something to keep in mind so you know if you're on the right track. 2.21 and 1.21. I believe that's correct. Let's take a look and see. There it is. Okay, so it's nice to have a little calculator handy. Really, all you need for the calculator is just your, handy dandy simple one. Oh, you can't see it. There it is. The one from the dollar store works just fine. Although the dollar store now has scientific calculators for sale. Go figure. All right. This one I believe is factorable. So we're going to end up with some nice fractions. We're not going to have to estimate them. So anyway, let's go ahead and put in our A is 5, B is 8, and C is 3. And I am going to just go a little faster now and getting it a little easier. P is equal to negative B plus or minus the square root of B squared plus the negative 4AC. I know you want to put minus 4. It's okay, it doesn't matter. All over 2A. And we just substitute. So 8 is B, A is 5, and C is 3. And we simplify this guy. And it looks like we're looking at negative 60 here. And we have a positive 64 right there. So we end up with a 4 under our radical. So negative 8 plus or minus, I'll go ahead and leave it as the square root of 4. It's just 64 minus 60. And it's all over 10. And that is going to be negative 8 plus or minus 2 over 10. And the way I like to do this one is I like to sometimes write it like this. When you need an exact answer, this is a good idea for writing it. I'm actually talking about negative 8 plus 2 over 10 and negative 8 minus 2 over 10. And this is negative 6 over 10, which reduces to negative 3/5. There's one of your roots or one of your solutions. And this is negative 10 over 10, which is negative 1. And there's your other solution. And it says we could write them as proper fractions if we want to. So I'm going to go ahead and put them in as proper fractions. Before I do that, let me just factor this. Remember at the very first I mentioned that it's factorable. Now, a lot of people are not going to be able to recognize a factorable quadratic that quickly, but you really should practice this so that you can factor these guys. I've got 5p squared plus 8p plus 3 equals 0. And this is the reason I like to be able to factor. I like to stack my factors. And I know the only way to get 5p squared is to take 5p times p. And the only way to factor 3 is 1 times 3. Well, when I cross multiply these, I need to get the 8p in the middle. So clearly, I need a 3 and a 1 to get the 5p this way when I cross multiply it, and the 3p this way. And when I add those middle terms, I get my 8p. And of course, with a little bit of practice, you can see it in your head. Now, of course, in order to get my solutions, I would just solve this equation. 5p plus 3 equals 0, and I get negative 3 over 5. And p plus 1 equals 0, and I get my negative 1. Anyway, there they are. Negative 1 and negative 3 over 5. And we're done. Okay. This one is, I believe, non-factorable. So we're going to end up with a little bit more trouble on this one, where our A, of course, is our 5, our B is 2, and our C is negative 5. And I'm going to put it in. In this case, D is equal to my negative B. I'll substitute still, plus or minus the square root of B squared plus negative 4 times A times C Notice I am substituting as I go, and it's all over 2a. Okay. Oh, okay, let's see. It looks like we're looking at 104 for our radical. This is positive 100, and there's the 4. So it looks like we end up with d is equal to negative 2 plus or minus the square root of 104 all over 10. Now, one of the things you run into problems with is anytime you have an even b, this radical can be reduced. And if you need an exact answer, like if I have an exact answer, you have to reduce that radical. That square root of 104 is really 4 times 26. So this is what you have to do. It's a long process, but I'm going to go ahead and just give you just a real quick insight in here. This is the square root of 4 times 26. And that means that I can take out that radical 4. This is the square root of 4 times the square root of 26. What I'm doing is reducing a radical, and that is 2 square root of 26. Now, eventually, you're probably going to be able to eliminate these two parts and go directly from here to here like I do. But at first, you're probably going to have to write them out. It just takes a little bit of practice, though. Now, 2 square root of 26 is the reduced version of the square root of 104. Now, if I'm doing the calculator thing anyway, it doesn't matter. So if you're going to do the calculator and just get an estimate, then it doesn't make any difference. But if you need an exact answer, and you sometimes will, you're going to have to do this. Now notice that I've got 2's in both of these. So I have to put this over 10 and this one over 10 so that I can reduce it. Or I can reduce both of them. Again, a lot of people are going to mess this up. This is negative 1 over 5 plus or minus the square root of 26 over 5. And of course, that's over 5, sorry. That's the same as negative 1 plus or minus the square root of 26 over 5. Now you'll notice that this doesn't look very much like this, and a lot of people are going to have problems with that. So I thought I'd give you those. We're interested in just getting an estimate, so I can just use the calculator. The square root of 104, oh, darn it, where's my, there it is approximately, when you take the square root, you're going to get approximately 0.20. But I'm going to go ahead and do it on the calculator here. Square root of 104 is 10.198. All over 10. And we can do the two parts here. The nice thing is that you don't really need to have a calculator to divide by 10. Just move the decimal one place. So we end up with negative 1.22. And when I add the 10.198, I end up with 8.2. I end up, oh, I better do it. No, I don't. Did I mess that up? I think I messed that up. I'm going to go ahead and just double check it real quick here. I know what's wrong with me. I end up with negative 12.198 over 10, which, yeah, it's negative 1.22. And the other one is going to be the 8.198. And we're going to move the decimal over, and we're going to get 0.982. No, 0.82. Jeez. Well, that's odd. I think that's right. All right. In this one, we have A is 4 and we have a 9 in the middle. I believe this is factorable. Now it's not, I can't take a common factor out, but I think it's factorable. So I think it's going to work out kind of nice. 4, our B is equal to 9, and our C is equal to -4. Oh, no, it's not factorable because it's a -4. I was thinking it was a +4. So let's go ahead and put it in. M then is going to be equal to -B, that's -9. I'm not going to put the parentheses till I get to the negative, and then I'll show you why. Plus or minus the square root of 9 squared. Again, I really only need the parentheses when I'm talking about negatives. Plus -4 times A times C, which is -64, and it's all over 2A, so 2 times 4. So we have 81 and 64, and we're going to add those up. That's the 81, and that's the +64. And I get -9 plus or minus the square root of 145, which is really close to 12, isn't it? Over 8. Yeah, that's 145, all right. So it's going to be like 12.05 or something. So let's take a look and see how close we got to 12. We're talking about the square root of 145 is 12.04, pretty close. Approximately -9 plus or minus 12.042 all over 8. So I'll go ahead and let's see, we're going to add the 9 and divide by 8. And remember, it's negative, so M is approximately -2.63. And the other one is going to be square root 145. And we're going to subtract the 9 this time and divide that by 8. 0.38 when I round to the 100th. And there you go. Again, a calculator is nice. I could do it without, but I definitely don't want to today. 2.63, 0.38. Now, they ended up not being exact conjugates. Remember, I said that they a lot of times will turn out to be conjugates, like 0.63 and 0.37 would be conjugates or equal. They're really close, but the reason that they're not exact is because we're rounding, and that messes it up a little bit. Anyway, there it is. So, all right, again, non-factorable. We've got A equals 4, B equals 4, and C equals 1. I'm going to go a little faster this time. W equals -4 plus or minus the square root of 4 squared plus -4 times 4 times 1 all over 2 times 4. You'll notice I'm not I'm substituting and doing the A, B, C in my head. So we've got -4 plus or minus the square root. This is 16 and this is -16. Oh, look at that. It is factorable after all. And in fact, it's a perfect square trinomial. Should have recognized it. That is -1/2, isn't it? We have -4 over 8, which is -1/2. Our factors were 2w plus 1, and of course 2w plus 1, and it's equal to 0. And of course, that would have been a much easier way to do the problem, wouldn't it? That is -1/2 and -1/2. We could probably do decimals just as easily, but there it is. Okay. Oh, this is a good one. Now, you can do this one almost instantaneously by factoring out the h. That would be a really easy way to do this. But of course, we're supposed to use quadratic formula. Notice that the c is 0 because there really is a +0 at the end of that, even though we don't see it. Here's our a, And our b is the -4. And this is where I was going to tell you, it's important that when you substitute your b in, you put the parentheses. So here we go. Our a is 9. Our b is the -4. And our c, sorry, that's supposed to be a tail on my b, is 0. So let's put this value, let's put all our values in there. We're going to have h is equal to -b. And this is what I was saying. A lot of people are going to do this, and then everything else they do is going to be wrong because it says -b or the opposite of b. Since b is -4, the opposite of -4 is +4. So you need to be really careful there. And a good way to do this is to substitute inside parentheses plus or minus the square root of b squared plus -4 times a times c. Of course, that's not going to turn into anything because that 0 is going to go in there, to a. So our -4 goes here, and notice that that is a +4. And our -4 goes here. Now, there are people who, you're going to be sorry, but here's what's going to happen. Instead of squaring the -4 in their head and realizing -4 times -4 is +16, they'll grab their calculator and they'll put this in their calculator. And they'll use the little x to the y key, or they'll use the little x squared key, and then they'll hit the equal sign, and their calculator says -16, and then they just turn their brain off and put -16 in. Here's the reason. This is -16, because what that literally says is -4 times 4. That is literally -16. But what we really wanted was the -4 inside parentheses. And that is -4 times -4. And that is +16. So be very careful. Parentheses are important when you're dealing with negatives anyway. Okay, so enough said on that. Okay, so we've got a +4. We've got plus or minus the square root of 16. This is going to be 0 because our a and c are going to get multiplied, and that's going to give us 0 right there. And it's all over 2a, which is 9. And that's going to be over 18. And it looks like we have 4 plus or minus 4 over 18, sorry. And that is 8 over 18, or 0 over 18. Well, that's just 0. You can divide into 0, you can divide by 0. And this reduces to 4 over 9, doesn't it? Now, we could have eliminated a lot of work by just factoring out the h. You see, this thing is really just h times 9h minus 4 equals 0. And you get two answers. You get the 0, and then you add the 4 and divide by 9, and you get the 4/9. That's why factoring is so nice. It just, quadratic formula always works, but factoring is just a beautiful alternative. 0, and of course our 4/9. Okay, shall we see if it's factorable? I believe it might be, could be, but I don't think so. I don't think it's factorable. So it is possible, but I don't think so. There's no common factor. Remember to always look for a common factor. That's important, because otherwise you're going to do a lot more work than you have to with your quadratic formula. So I have a is equal to 4, b is equal to -6, be careful with the parentheses, and c is equal to -7. So we're going to say j is equal to -b plus or minus the square root of b squared plus -4 times a times c all over 2a. So j is equal to 6 plus or minus. Well, that's 36 right there. And this piece is going to be 16 times 7. And 16 times 7 is 112? 16. I can't multiply today for some reason. Yeah, 16 times 7. Yeah, it's 112. And so we have 148. Yeah, plus or minus the square root of 148 all over 8. Now, one more time, just real quick. Anytime you have an even b and you get you want an exact answer, absolutely are going to have to reduce the radical. It just is the way it is, and there's no way around it except to complete the square, which would be a lot worse. So we're just going to deal with it, okay? So anyway, I'm just going to go ahead and use my calculator. I'm going to be really lazy and do 6 plus or minus. The square root of 148 is going to be 12.2 more or less. And it's going to be, let's see, square root of 148, 12.166 if I round it over 8. And so I'm going to, let's start by subtracting my 6 and dividing by 8, and that'll be my negative part. So j is approximately negative 0.77. And then I'm going to do my addition. Square root of 148 plus my 6 divided by 8. And we get our 2.27. And again, I didn't get my conjugates like I was expecting. They're like almost conjugates, I should have said. So anyway, there it is. We've got a negative. Don't forget to put the 0 in your decimal. They don't like it when you put a point without a 0. And 2.27, I believe those are correct. Okay. I think we've gone probably into all that you need to. I may do just another one. I don't want to go for too long because it's been 30 minutes already. This is a kind of a weird situation. I have an a that's negative. Don't usually see that very often. This is definitely non-factorable. So a is -1. Remember, there is a 1 in front of there, even though we don't see it. B is 2. And C is 7. So let's put it in. My y in this case is equal to -b plus or minus the square root of b squared plus -4 times a times c all over, and I should put parentheses, I guess, 2 times -1. And we're going to get -2 plus or minus the square root of 4 and 28, which is 32, all over -2. And we're going to get two answers. Let's put our approximation here. -2 plus or minus, looks like it's going to be about, I don't know, 5.6 more or less, all over -2. So let's do our square root of 32. 5.657. Okay, so we're going to add the 2, divide by 2, and we get about 3.8. 3.83, and then I'm going to do the difference, which is square root of 32, and we are going to subtract the 2 and divide by 2. This is going to be our negative part. negative 1.83. And as I said, the decimals a lot of times will match up. Okay, so by the way, the sum of these two ends up being positive 2, doesn't it? Remember that the sum has to work out. Something to think about. Anyway, looks like negative 1.83 and 3.83. I believe it's correct. And yeah, I think it's okay. All right, I'll do one more. We get that 0 again. In this particular case, it might actually be easier to divide everything by negative 3 before I ever started. A good idea whenever you have a quadratic of any kind and it has a common factor, just divide all the terms by it. I'll show you what I mean. You see, instead of having to deal with the negative 6 and the 9 in the quadratic formula, and in other ways, I added my 0 on my C term. But notice that all of these terms are divisible by negative 3. And I just want to show you something here. Now, you don't have to do this. It will work if you just put in A is negative 6 and B is 9 and C is 0. But notice that this is the same as 2k squared minus 3k plus 0, of course, is equal to 0. Now, this and that one are all the same. So you can use A equals 2, B is negative 3, and C is 0. Or you could use A equals negative 6, B equals 9, and C equals 0. And either way, you're going to get your two solutions. Now, I'm going to be a little bit lazy and just show you what I mean. You see, if I take 2k squared minus 3k equals 0, if I factor out the k, I get k times 2k minus 3, and I have my two solutions, which are 0 and 3/2. If I write it from the original, negative 6k squared plus 9k equals 0, and I factor out the negative 3k, which is what my common factor is, I end up with 2k minus 3 equals 0, and I get the same two solutions. I get 0 from this one, and I get the positive 3/2 from that one. 0 and 3/2. I'm not going to put it in the quadratic formula. I know you guys can. I'm going to cheat a little. There it is. And to get to at least to this proficiency, do some more and practice your quadratic formula so you'll get really good at it. And I'll see you back again. Bye, guys.